To say that an atom is not there until it is observed is a bit like saying that a video is not there until you click on it. There is a similarity between the two because we have to come in contact with an atom to do a measurement, just as we have to come in contact with the computer to see a video. In quantum mechanics, this is called the measurement problem, and I have placed a link below this video to my main video on the measurement problem that explains it more scientifically and mathematically. But in this video, I want to create an intuitive picture of why people can say an atom is not there until you try to measure it. If we think of the universe as a process in the form of a continuum that is relative to the atoms of the periodic table and the individual wavelengths of the electromagnetic spectrum, we experience this process of energy exchange as the ever-changing world of our everyday life and measure it as a period of time with an uncertain future that is relative to the energy and momentum of our actions. This is because we are made of atoms and are therefore part of the interactive process. When we look down at individual atoms, we only see probability until we interact with the atoms. This is totally logical because we have an ever-changing future unfolding relative to the atoms, with the spontaneous absorption and emission of light photon energy. This is a universal process. If we light a candle or turn an electric light on, we create photon energy. If our eyes were more sensitive to the different wavelengths of the electromagnetic spectrum, we would see that everything is radiating light continuously. Light never stops propagating and is radiating out relative to each object and life form. The forward momentum of light and what we see and feel as the forward passage of time, or arrow of time, is formed by the same process. This can be seen in the simple fact that light always moves from the past into the future. Within such a process, the wave-particle duality of light and matter in the form of electrons is forming an interactive process. Light and the electron probability cloud that surrounds the nucleus of an atom are waves and only have particle characteristics when there is an interaction. This interaction is formed by the absorption and emission of light waves, forming an exchange of photon energy. By the word measurement, we mean interact with the atoms by turning on an electronic detector. As a process of continuous energy exchange or continuous creation, the atom does not have an exact position in space and time relative to the measurement device until measured. Because classical physics of our everyday life is based on quantum mechanics, this is a bit like saying that a video is not there until you click on it. We have to come in contact with the electron probability cloud that surrounds the nucleus of an atom to do a measurement, and this creates a photon-electron coupling or dipole moment relative to our actions. Because we are an interactive part of this process, we can say an atom is not there until we try to measure it. But it is more logical to say that as a process of continuous energy exchange or continuous creation, the atom does not have an exact position in space and time relative to our actions before we make contact with it by turning on an electronic detector. Thanks for watching. Please sub and share. It will help the promotion of this theory.